Hello, my name is John Reese, and I'm going to be demoing the quadratic formula solver application. So as a quick history, the quadratic formula is used to find the x-intercepts of a graph. If you are given an equation, say ax squared plus bx plus c equals 0, if you want to get x on the left-hand side of that equation, you would get a formula that looks something like this, negative b plus or minus square root of b squared minus 4ac over 2a. And this will allow you to find, to solve for x and to find a given x-intercept. So in this application, if we were to type in 1 for a, 4 for b, and 1 for c, we'll hit the submit button and the program will have to think about it for a little bit. And we'll see negative 0.267 as the result. Now there should be 2 here for both x-intercepts on the graph because there's a plus or minus here, but this application only focuses on the plus portion of the formula. So now the application seems pretty simple at first glance. I mean, it's a mathematical operation. We should be able to plug all these values in and get a result back, which we are. But in order to stay true to the scope of the project, actually each of these operations are actually a web service call. So we see here that there's an addition, there's also a square root, there is a square operation, multiplication, and division. So in order to perform this calculation, there are actually 5 web service calls. And there's also some logic in the BPEL process that will actually check to see if the result of the square service and the multiplication service subtracted those 2 results turn into a negative value, which would be a negative square root. And a negative square root will give us an imaginary number. So for an example, if we were to do 0 for A and 0 for B, as well as 0 for C, hit the submit button. This will come back a little bit quicker because there's not as many calls as we need to make. We get no solution. If we're dealing with imaginary numbers, there might be, but in this case we're just going to say that there is no solution. And we can see this at work here by going to the BPEL process graph. And there's, after we are able to get the value to get root, after we invoke the subtract service, there's a branch here stating if the value is negative to reply as a failure, otherwise continue on making the additional calls. And that's just a simple way to don't bother calculating or calling the other services because we already know that in this case there won't be another solution. So if we go back to 1 for A, 4 for B, and 1 for C, and we hit submit, there really wasn't a way to test this in terms of unit tests because it's all based on services. The only way to ensure that it's going to function correctly is if we did some sort of integration testing. So in order to test this, I just ensured that math.com has a quadratic equation solver, and we can type in values for A, B, and C, 1, 4, 1 respectively, and we can see here that the x1 value, the plus value, is negative 0.267, which is the same value here. And again, this just gives us confidence that the program is working as expected.